Welcome back to Wings Lecture. This is Vetri. In this video, we are going to see about Dijistra's algorithm. Okay, so one of the important applications of graph theory, which is finding the shortest path from the graph. Okay, from one node to another node, or else one vertex to another vertex, or else one location to another location. Okay, so by using Dijistra's algorithm, we are going to find out the shortest path between the nodes. Okay, see here I have the graph, and A is going to be the starting vertex. From A I am going to find out the shortest distance from A. Okay, from A I am going to find out the shortest distance between these nodes. Okay, and here we have the condition, which is the Dijistra's formula. It has to satisfy this formula, right? See, d of v, we have to define the value of d of v, which is distance of v. So here we have the two vertex and one edge. Okay, so to understand this formula, just listen. Here d of v, I'm going to find out the distance of v from u. Okay, so here we have only one edge, so don't confuse with that. We will be having multiple options, so just for understanding I'm keeping this. Okay, so d of v is equal to, it has to satisfy if d of u, which means this value, d of u is this value plus cost of u comma v, which means the distance of u comma v, which is 3. Okay, so we have to add these two and we have to compare with the previously defined distance. Okay, what is the defined distance? Which is 7. See, just add these two. If 2 plus 3 less than 7, what is the value? 2 plus 3 is 5, less than 7. See, previously defined value is higher than the newly optimized value, right? So what we have to do is d of v, we have to update the value of d of v by using this value. Okay, the newly optimized value, right? Newly optimized distance. So we have to update this value here. Just remove 7 and update 7 by 5. Okay, so that's the concept. By using this logic only, we are going to proceed the problem. Okay, so if you are not able to understand this, so I will explain the same in problem also. Listen carefully. Usually in all the problems, they will give the starting vertex, which is going to be your starting vertex, or else you can choose any vertex as starting vertex. Okay, that's not an issue. See here, they have given the vertex A as starting vertex. Okay, see, now first step, what you have to do is, so you, for the initial step, we were going to start the travel from home. Just consider as home. Okay, so from home there won't be any distance, right? We are that's the location we are starting, right? So you have to keep the distance of A as 0. Okay, that's going to be 0. And for other location, from home you are going to visit B, D, C, E. Exactly, you don't know the current distance between those locations, right? So what you have to do is just to keep infinity, because you don't know the distance, right? So you have to keep infinity as the distance at first step. Okay, and you have to separate the graph by levels. Okay, so we can keep the levels as 0. This is 0 level and 1, 2. Okay, so levels, which is nothing but the order. Okay, so sometimes it can vary, that depends on the graph. Okay, now, so by using this formula, first I am going to find out. See, there won't be any changes in the distance of starting vertex. Okay, so no need to disturb it. And from A to B, so here is the formula. Distance of B is equal to, so by applying this formula, see here d of u is 0 plus cost of u comma b. Here what is v? B. Okay, so what is the distance? 4. And what is the previous distance? Already defined distance, it is unknown, which means infinity. Okay, so 4 is definitely less than infinity, so directly we can update the value there. Okay, 4, so that's the updated value. And then similarly for d of b is going to be 4 now. And on the second level, in the first level, which one is going to be the second one? See, C, d of C. Now find out d of A is 0 and A to C is 8 and less than infinity. So obviously 8 is less than infinity, so we can update the value. For first level, there won't be any confusion, okay, to comparing the distance, right? Usually it will be infinity, so no need to disturb it. Okay, now it is going to be 8, so you can update it here, 8, right? Next, so we have completed the level 1. Then find out the distance. You can go to next level. So before to that, what you have to do is just find out, you have to keep the available distance, right? So now we have choose 2 vertex from level 1, which is from level 1, what are the available vertexes? Distance 4 and 8. So which one is minimum? Minimum is 4, right? 4 is the distance of B. So you have to choose this vertex to travel towards the next one. Okay, so what I am going to do is, so now the level 1 is completed. Okay, and then find out what are the outgoing vertex from B. Okay, so just assume yourself, now we have reached one junction from home, and then you are going to find out, you just asking someone what is going to be the distance to the next area or next city or else to next village. Just you are in the junction now, and you are going to decide which one you are going to choose. So here I have 2 options, 4 and 8. Okay, so now I'm in 4, so I am choosing 4. Why? Because it's lesser distance. Okay, and then now I have chosen B, vertex B. Okay, so now find out the distance from B. What are the possibilities are there? From we can go to A, and we can go to C, and we can go to D. So there are 3 options, right? Just write one by one. From B, distance from B to A and B to C and B to D. See, B to A already visited one, right? So from where we have started the travel? A. So we have gone through A, right? So no need to disturb it. Okay, so it's already visited. So what is going to be the next one? B to C. See, already I have the value to reach the destination C. The distance is going to be 8, right? So now find out the distance. Now we are going to find out the distance. Okay, because to reach C I have 2 options. Okay, either I can travel from A to C, or else I can go through like this, A to B and B to C. So the main thing is you have to find out the optimal distance, shortest distance. Okay, so by applying this formula, From B to C, what is going to be? C. From B, what is the distance? 4, this one. And from cost of U comma V means cost of B to C. What is the distance to reach from B to C? Which is 1, which is less than 8. Which one is going to be the defined distance? In previous step we have defined, right? And the defined distance 8. And but the newly optimized distance is less than the previously optimized distance. Okay, so which is 5 here, and it's less than 8. So what you have to do is you have to update that newly optimized value, newly optimized distance here. Okay, that is going to be 5 now, right? So I hope you understood. So still if you have any confusion on this step, just repeat once again. Okay, so from D to B, from B to C is going to be 5, and from B to D, C, from B to D, apply the same formula. What is the value of B here? 4 plus B to D is 3. The defined value of defined distance of D is, what is it? Infinity, right? These are levels, okay? Don't confuse with those values, okay? Now the value is 7, which is obviously it's less than infinity. So just update the value here as 7. Okay, now it's going to be 7, right? Now write the available distance. What are the available distance after reaching that stage? Okay, now we can simply write the available distance are 0, 5 and 7. 0 is already visited, which means A, so no need to write this. So the available distance is 5 and 7. So which one is minimum? 5 is minimum, and 5 is belongs to which vertex? Which is C. 5 is belongs to C, right? So I am going to choose this vertex on next level. Okay, and then choose C. So from here I am going to start my travel. Okay, now find out what are the available vertex from C to other vertexes. See, you are having all the options. So we can go to A, we can go to B, and we can go to D, as well as we can go to E also. Now first let me write the possible routes. Okay, from C to A, from C to B. So you can write like this also, that's not an issue. Okay, it's all for understanding. And from C to D, and from C to E. Okay, so these are the 4 available edges, that means option. Okay, now C to A is already visited, right? So which is already visited. Then from C to B, that's also already visited. And from C to D, we are going to find out now. Okay, now find out what is the distance, which means here U and V. Just apply the formula, same formula, 5 this value, and plus cost of U comma V. So what is the cost? 7. And what is the defined value of D, which is already 7. Okay, now find out the value. 12 less than 7. Here the defined value is less than the newly optimized value. 12 is big, right? So 12 is big and 7 is the minimum one. So what you have to do is just don't disturb. Okay, so do not disturb the current value. Only you have to change the value, only you have to update the value when the newly optimized value, this area, okay, which is lesser than the previously optimized value or previously defined value, that means distance. Okay, so it remains same. And from C to E, which is, so current value is 5 and the distance is 3, and what's going to be the defined value is infinity. So definitely we have to update, because infinity is 8 is less than infinity, right? So we can update it. For each step you have to update on the diagram. Okay, so that's the key thing when you are trying to deal with the graph problems. Okay, for each and every step you have to update your graph, then only you get the clear idea. Now see, now find out what are the nodes location visited. Already A is visited, B is visited, C is visited, and next write the available distance 7 and 8. Okay, so which one is going to be the minimum? 7 is going to be minimum, and 7 is belongs to D. Okay, 7 is belongs to D. So obviously next we are going to visit D. Okay, choose D, and then from D find out what are the available routes. Okay, from D I can go to B, and from D I can go to C, and from D I can go to E as well. Okay, so I have 3 routes, right? Okay, so D to B already visited, and D to C, that's also visited. See, after visiting you can strike out the vertices. Okay, that will be more helpful. Already visited. And for D to E, see, it's not visited yet, right? So just find out by applying the same formula. So what is the cost already? What is the distance of 7? Sorry, D, which is 7, and the distance between D to E is 8. Which one is the previously defined value is already 8. So 8 plus 7 plus 8 is going to be 15, less than 8. So the previously defined value is already less than the newly optimized value. So do not disturb. Okay, so it's not satisfying, so don't disturb the previous value, right? So it remains same, so don't disturb on this location. Okay, so that's it. Now we have only one option, the available vertex or distance is 8 only, right? Because these two are already visited, so just choose 8 because we have only one left. So 8 is belongs to E. Okay, so actually this step is no need, because we know that from E everything is visited already, right? So for presentation you have to write from D to distance of, what are the available option? 2 options are there, E to D and E to C. So already visited, and it's already visited E to C also, right? So that's it. Now we have find out all the shortest path from A. Okay, so what is the final step? The final step is going to be, right? So we have visited all the vertexes. What you have to write is from A. Okay, from A, just write the vertex here and distance. This is going to be the final table. Okay, So A to A, it's definitely it's 0, right? And usually it won't happen. Then from A to B, it's going to be, which means we can write it like this. From vertex A, so A to A is going to be 0 to reach distance vertex B. What is the final value? 4 for C, 5 for D, what is it? 7, and for E it's going to be 8. Okay, so that's the final output. So after that you have to draw the diagram as well. Okay, A, B, C, D, E. So the values are 0, 4, 5, 7 and 8. Okay, so that is the final output, right? So for each vertex from A to that particular vertex, you can draw a separate diagram also if they asked. For example, they used to ask like that, find the shortest distance from A to A to E. So what is going to be the shortest distance? Means we have to draw only that particular vertexes. Okay, so which is A, B and then E. So just find out 4 plus 1, 5, 5 plus 3, 8, right? So the concepts are very simple, and don't consider this one as a formula. Okay, so you can do a mind calculation also, but for the namesake you have to apply this formula in the notebooks, in the answer book. Okay, otherwise it will not convince the examiner to give proper mark, that means enough marks, right? So that's it, and one of the important applications of graph theory, and I hope you understood the logics very well. And just try to repeat the video if you have any doubts, right? And you can comment in comment section also. And thanks for watching, and if you have any doubts, just repeat the video once again, right? Otherwise you will not get a clear idea about Dijkstra's algorithm. Okay, so one of the important algorithm in graph theory, which is Dijkstra's algorithm. And thank you.